So the Cartesian coordinate system can be used to organize data. And graphs are really helpful in that. So by organizing information on a Cartesian coordinate system, you can begin to see patterns. Moving on to the next page, you're supposed to label each graph with either positive, negative, or no correlation. Well, positive correlation is going to be going up, negative correlation is going to be going down, and no correlation means it's just going to be kind of all over the place. So the first graph here, the one with the dollar signs, is positive. The one about the top running speed is negative. The one with the dice roll and the age is no correlation. And the total sales is going to be positive because it is going up. So the data points on a graph that have positive correlation tend to go up and to the right. The data points on a graph that have negative correlation tend to go down to the right. The data points on a graph that have no correlation appear to be scattered. They're literally just everywhere. So the value measured on the horizontal axis is the independent variable. And the value measured on the vertical axis is the dependent variable. And the reason it's called dependent is because it depends on something else. So looking back at this graph up here about the top running speeds and age, what that's saying is that this is the independent axis. And this one, the top running speed, is the dependent axis. And that means that the top running speed depends on your age, which makes complete logical sense. So moving on to where it says page 13. A line of best fit will always go through the middle of the data points, and you can use this line to see general trends and make approximations. And when data lines do not lie on the line of best fit, we say that they tend from it. So how we use lines of best fit. I'm looking at these four graphs that you saw on the previous page. And a line of best fit is a line that kind of goes through the middle of the data as best as you possibly can get it. So for this first graph, income in thousands and years of education. So what this graph is predicting is based on how many years of education you have, what your average income in years should be. So a line of best fit, or a trend line, because they're the same thing, would be a line that kind of goes through the best as possible the middle of all the points. It would look something like this, and we use this line to make predictions. So what we would say is that a person who has 13 years of education is probably going to make about $30,000. And if you want to know how much a person with 18 years of education would make, then they're probably going to make somewhere around $48,000. So it doesn't necessarily mean that the points are not going to always be on the line. Looking at the one with the top running speeds and the age, a line of best fit would probably look something like this. It goes through, again, the middle of the data. It doesn't go through all the points. That's not possible. So at the age of 50, to have a top running speed of about 12 to 13. Now, for the dice roll, we can't actually draw a trend line because there is no pattern for us to follow. For the total sales, we could draw a trend line, but it looks like these sales actually are pretty linear themselves, and so most of the times our points would actually be on those lines. But for these two graphs especially, we can use our trend lines to help us make predictions. For questions 1 through 5, we're supposed to use the temperature data recorded in the table above to answer the graphing questions that follow. So number 1 says, what would be the ordered pair for the week 7 high temperature? So if I wanted to know the week 7 high temperature, essentially I'm ignoring this low temperature column, but just for this question. So week 7 had a high temperature of 90. So that would be my answer for number 1. For number 2, it asked me, what would be the ordered pair for the week 7 low temperature? So this time, I need the low temperature column, but I don't need the high temperature column, so I'm basically ignoring that. So the week 7 low temperature would be 7, 58. For number 5, what would be the ordered pair for the week 10 low temperature? So again, I'm ignoring the high column, so it would be 10, 51. So you'll be responsible for doing 3 and 4. Question 7 says, what would be considered the ordered pair for the day 1 low temperature? So I'm ignoring the high column, so my day 1 gave me a low temperature of 5. And number 9, what would be the ordered pair for the day 7 high temperature? Well, day 7 had a high of 26.